Good night, everyone. I hope that you can hear me. Good night, Kyle. Jonathan, good to have you. Jamila. Zeph. Hi, Marlon. Hope you're okay. All right, Vassal. Marco J is here. Campbell. All right, King. Hi, Akelia. Mills. All right, Zeph. Thanks for that. Leotastic. Ray J. Musically X. Yes, Sir Walker. Good night to you. Welcome to the panelists as well. Hi, Bailey. Amari K. Shade. Morrison, I see Krishante as well. All right. Let's see. Panelists, are you able to hear me clearly?
Yes, sir.
All right, great. That sounds like test. Is Brianna there? No, she's not. Let's see if we can get her back online. Let's go to a few more persons saying good night here. Leonie, yes. Some names I can't call. All right, Gamer 35. All right. So good night, good night, good night, everyone that's here with us again. This looks like Dacia, yeah, and Kyle, Mason, okay, Nugent. All right, cool. Let me see. Booth. All right, guys. So let's get to it. Um, we looked at the verbal reasoning section last night, and we're going to jump over to the quantitative reasoning section of our book. Where I think we're in book 3 now. All right. There's one more book to go. So we're at section 2. Okay. So section 2, quantitative reasoning. And let's go with our questions here. Item 12 and 13, the item type is quantitative reasoning, the category problem solving, the targeted skills, analysis, and we to analyze rather, interpret and solve problems. Here is the scenario. Remember that in the ability test, a lot of times we can have a background, a context, a scenario within which the question is framed. So we encourage you to read this scenario properly so you can understand what is happening. We encourage a strategy called 3 reads. You read it once to get the general idea, then you read it again looking for, what operations, what are the units, do the units need to be converted from one to another, and so on. And then you read it once more the last time around to see specifically what question needs to be answered. So that strategy is called 3 reads. So let's go. Night, I'm seeing Gabby just joining, Jada and Morris. All right. It says here, use the information below to answer item 12 and 13. Okay. So just looking at this now, first time round, I see that we have something here that goes horizontally, that is 2 meters, and this goes from top to bottom, or vertically 90 meters. All right, I'm not sure what it is yet, but I have observed that. It says the diagram above shows the design of a handrail for a length of walkway for a school located 400 meters from the beach. The horizontal bars each measure 2 meters. The vertical bars each measure 90 meters. And the handrail is designed with 5 decorative stars. Okay, so I'm seeing the 2 meters there. I'm seeing the 90. Let's see, 1, 2, 3, 4, 5. I'm seeing 5. I guess these would be the stars then, the 5 stars. Okay, let's see now. So we get this. Let's see what their hint is. Use the information given in the question, and you're going to have to make some calculations. All right, all right. What's the question? Let's get Tess. Tess, could you read the question?
Yes, sir. Are you hearing me, sir?
Yes, I'm hearing you loud and clear. Go ahead.
Yes, so the question says a student wants to use the same design to cover 6 meters. How many decorative stars would be needed for the handrail?
So hang on a second. Let's go to what we know now. What do we know? Let me see if I can get our pencil here. Okay, pencil. What do we know in this? We know something
Yes,
about
sir.
2 meters here.
We
True.
know that one of the horizontal bars
Mm-hmm.
measures 2 meters, and
Mm-hmm.
the vertical bars or the rails measure 90 centimeters each.
All right. So, um, where do we go? Because they want to use the same design to go 6 meters here. Hmm? So is that increasing it or decreasing it?
Increasing it, sir, for the horizontal bars. So, sir,
What?
we could look at this in a ratio way. So, 2 meters would be equal to 5 decorative stars. So, 4 meters would
Mm-hmm.
be equal to 10 decorative stars.
Mm-hmm.
And that means 6 meters would be equal to 15 decorative stars.
Interesting. Okay, like you're working on that. So of the options 5, 10, 30, and 15, you say that it would be 15,
These are
15 that would be needed. All right, good reasoning there. Still with you. Let's okay, give me a second. Let me see if I can pull our camera up here and then switch to the camera and see if this can help some of us to visualize it. Hang on a second. Let's see if we can get this here. Okay. All right. Hopefully this is bright enough for you to see. So here we go. This is what we have, 2 meters with 5 stars, and we're going to put on another 2 meters here with 5 stars again, and 2 meters there with 5 stars, because 2, 4, and 6 giving us a total of what? Of 6 meters in all. So if I had 5 here, another 5, then we have another 5, and this will give us 15 stars in all. Okay, so for those who want to see it, you could do something like that. Okay, um let's go to 13. Let's go back to our questions here. 13. All right, cool. 13, 13, 13. Read for me.
yes, sir. So it
Mhm.
says, what is the total length of horizontal bars needed to make the 6 meter handrail?
Hold on, they say horizontal bars.
Yes, sir.
Singular or plural?
Plural.
So how horizontal bars come in this?
Sir, at the top there, the black ones that measures 2 meters each, that would be the horizontal bar.
Oh.
And the one at the bottom as well.
Oh. So that's why they said bars. Okay, so we have
Yes, sir.
top and bottom. All right. So for the 6 meters, what would be the total then?
Yes, sir. So since right now we have the one bar measuring 2 meters, which means
Mm-hmm.
that we would need 6 meters at the top and also 6 meters at the bottom.
Mm-hmm. What's the total? Would it be 6, 12, 18, or 24 meters?
So, sir, that would be 12.
All right. So we'll take that as 12 meters, right? Why?
Yes, sir.
Because the horizontal bar is at the top and the bottom. And then we would say 6 times 2, giving us the 12. Okay. So
Yes,
that's
sir.
what we would use there. Good reasoning, good thinking with that one. Thank you very much. All right. Let's go. Let's go with this one here. Let me see. Yes. So questions, items 14 to 16, quantitative reasoning again, but this time logical deductions. We want to analyze and interpret data, and we want to draw some conclusions as well. Let's go here. It says the table below shows nutrition facts about a container of mac and cheese pie. Use the information to answer item 14 and 15. So this is Shaq's macaroni and cheese pie. nutrition facts. Here we have serving size half cup, or and it has 228 grams. Serving per container 3. Okay, amount per serving in terms of calories 240, calories from fat 110, and this would be the percentage daily value. So total fat, you get 16% per serving. And remember that this container has 3 such servings. Saturated fat, we'll get 15% of the daily amount. The trans fat, 1%. Cholesterol, 30%. Sodium, 15%. Total carbohydrate, 24%. Proteins, 10 grams. Vitamin C, 2%. Vitamin C, 3%. Cholesterol, 2025 2,500. Total carbohydrates 300 grams. The total daily value would be 375 grams. All right, so setup here, looking at the label and trying to understand what's there. Got that context, panelists, people on YouTube? Hope that you're understanding what's the context, right? And this is a part of science, in terms of looking the importance of labels. Labels are important. They carry information about the product, not only about the product, but also warnings and so on. These things help you. So if someone is not supposed to take in a certain amount of salt, they could look at the container and see the amount of what? Sodium that is there. Okay. And they can then use that now to make what? Some decisions about what they will consume. All right. So your diet is very important. Let's go then a little further. Let's see what it says. Question 14. But here's the tip. Could you read the tip for me, Brianna?
Yes, sir. Analyze the data given on the label. Use this to answer the question.
So it says here, this one, Merrick ate 3 servings of mac and cheese. What percentage of the daily value for total fat did he eat? Let's look at this. So we're looking at total fat. He ate 3 servings. What percentage of the daily value? All right, so let's go. 3 servings here. How many amounts here in the 3 servings? This is per serving here. Let's go. So let's see. Total fat is what percentage?
16%.
And he had 3 servings. So what would he have in all?
48.
Okay, how you get the 48?
Because you multiply 3 multiplied by 16.
Good. So 3 servings of 16% would give you what? 48% in all. Okay, so you multiply that 3 and the 16 there to get our 48. Thank you very much for that one. Still with you. How many? Question 15 now. It says always recheck your calculations and use all the information given in the question. Okay, so you double check. Let's go with this one. How many calories did Merrick consume? How many calories did Merrick consume? All right, so we're looking for calories now. 3 servings. Yeah, 3 servings. Let's look for the calories here. Let's go. We have amount of calories per serving, and he had 240 3 times. What's your answer?
240 multiplied by 3 is 720.
720. 3 times 0 is 0. 3 4 is 12. Right, 2 carry 1, 3 twos, 6, and 1, 7. So 720 in all. Let's see, do we have a 720 here? Yes, we do. Thank you very much for that as well. Okay, let's, all right, let's go. Just checking. 720 says 10. Um, let's go here. 720. Hope 720. Let's see. Let me see. All right. Evans says 240 by 3, 720. Let's see. Morris. Okay, great. You guys are on the ball there. Let's go to 16. For 16, it says for item 16, a seed box has 12 tomato seeds planted. Some of the tomato plants did not germinate. Okay. If 9 plants germinated, what percentage of the plants did not germinate? Let's hear Tess. What say you on this one?
Yes, sir. So, one box has 12 tomato seeds,
Mm-hmm.
and it says that some of the tomato plants did not germinate. And if 9 plants germinated, what percentage of the plant did not germinate?
Mm-hmm.
So, sir, we could find the highest common factor for both 9 and 3, because if 9 germinated, that means 3 seeds did not germinate.
Mm-hmm.
So the
Let's
highest common
continue.
factor for both 9 and 3 would and 12 would be 3.
Mm-hmm.
So, sir, if we divide 3 into 12, that would be 4.
Mm-hmm.
So that would be 25% for every three seeds. So if
Mm-hmm.
there are if 9 seeds did germinate, we'll multiply 25 by 3, and that will be 75% for the 9.
Mm-hmm.
And we know that in all we would have 100%. So we'd subtract 75% from 100%, and that would leave us with 25%.
Wow. Good reasoning there. We could take a slightly simpler approach. Let me see if we can get our, okay, all right. So we hear that out of the 12, 9 of 12 germinated, and we know that based on what you said, 3 did not germinate. Okay? So what, let's get this as a fraction then. Okay? So what is 3 out of 12 as a fraction? You said 3 into itself one time there, 3 into this, 4. So this would be a quarter when reduced. And as a percentage, if
Yes,
we
sir.
go by 100, then this would be equal to what? 25. All right, so 25%. So the amount that did not germinate would be what? 25%. Okay, all good on that one?
Yes, sir.
All right, cool. All right, great. Let's go item 17. Let's go back to 17. Quantitative reasoning still, data analysis, comparing quantities, analyze and interpret data, and compare. This is interesting. We have a pie chart. Let's ask our friends on YouTube, what else could they call a pie chart? Some people call it something else. Let's wait for a response. Some people call it a graph as well, but they call it another type of graph. Anybody? Circle chart. Okay, circle graph. I'm seeing here as answers coming in. So Campbell says circle graph. Musically says circle chat. All right, so let's be aware that it could be called something else. If we meet on another way to describe this, we know we're still using talking about the same thing. All right, the same setup. All right, so let's go. The pie chart below shows the categories of wastes collected from Jamaican households. Now, we know in science that taking care of our environment means disposing of our waste properly. So we talk about bag it and bin it, okay? And we know about the Not Dirty Up Jamaica campaign and all of those things. And at schools, we'll have special recycling areas, and we put plastics together and bottles together and paper together and all of that. Let's look at this chart now. All right. So NSWMA waste categories. So we have wood and grass clippings making up, Brianna, what percentage here?
37%.
What about food waste? Food waste.
16%.
Plastics, plastic bags,
15%.
solid plastics,
15%.
textiles,
Textiles. 10%.
glass,
4%.
and metals.
3%.
All right. So we see that when the garbage truck comes around, right? It's collecting a variety of things. Okay. It says here the National Solid Waste Management Authority, the NSWMA, has suggested that portions of the waste can decompose and they should be composted. All right. What percentage of the waste should be composted? Put into a compost. Let's look at this. Let's go back to the science now. What materials can decompose? Let's think about that. Let me hear from our friends on YouTube. Do plastics decompose? Friends on YouTube, plastics, do they decompose? If I take a piece of plastic and put it outside, will it decompose? Will it break down? All right, so I'm getting a few no's here. What about textiles? Will textiles break down? Textiles like maybe some old clothes and so on. Will they break down? What about glass and metal? Okay, so I'm getting suggestions here. The food waste will break down, okay, and they're saying here that the wood and grass clippings will also break down. So in terms, Brianna, in terms of things that we could have break down or put into a compost, what areas would you include?
Sir, I would include wood and grass.
And anything else?
Clippings.
No, the wood and grass clippings, yes, that's one thing, and that makes up how much here of our overall collections?
37%.
And the anything else you would add to the compost?
Yes, sir. Food waste.
Good. All right, cool. Now let's see what it says here in terms of a suggestion. Use the data in the graph and recheck your calculations. Always saying that, make sure you check your work. Now it says, what percentage of the waste should be composted? Is it 16, 37, 53%, or 47%? Let's go, Brianna. What's your thinking on that in terms of an answer?
Sir, I would add food waste and wood and grass chippings, which is 37 and 16, which would make 53.
All right. 53 yam, banana, carrot, or dumpling. 53 what? You
Percent.
mean? Good. All right. Remember your units, please. Let's go with this. So, wood, grass, and food can decompose. There's a word that we use. Bio something. What's that word? Bio
Biodegradable?
biodegradable. Very good. So things that are biodegradable, we know that over time, if we bury them, if we put them in a compost, they will do what? They will go away. There are decomposers that will work on them, right? And they will eventually go away. But the glass and the plastic, you're not going to see those moving anytime near now. They could be there for 100, 200, 300, 400 years before um, anything even remotely looks like them breaking down. Okay. Let's go on. We're at number 18. We need to analyze, interpret data, and draw conclusions. Let's get Tess. This one is yours. Read for me.
Yes, sir. So, question 18. A student conducted an investigation on the effect of fertilizer on the height of red peas grown over a period of 4 weeks.
Mm-hmm.
The student's results were placed on the chart below.
All right. So, as good scientists, we conduct investigations to find out certain things. We might have, some ideas and we want to test them out. So we conduct an investigation. And as good scientists, we record. Hmm? So we are going to put things on charts and graphs and put them in tables so that we can draw some conclusions from them. Let's look. What do they have here? They have a what?
Yes, sir. So, on the y-axis, it is
Mhm.
representing the height of plants in centimeters.
And they start in terms of what? From zero and they go up by?
5 each time.
Okay, so 0, 5, 10, 15, 20, and 25. On the x-axis, what do they have?
They are showing the amount of fertilizer in grams.
Mm. So overall, what are they trying? This chart represents the what? The effect of.
Fertilizer on plant height.
All right. So let me see. How do I interpret this information? Tell me how. What? What do I do? What do I say? What's the scientist in you telling me when I look at this?
Yes, sir. So it would show that the bar show how much fertilizer they put on each plant and
Mm-hmm.
the height of the plant after they add the amount of
So
fertilizer.
let's start with this one. What does this mean?
So they didn't put any fertilizer on it.
And the plant went up to.
About 12
Mhm.
centimeters.
All right, cool. In this setup, they added
5
and
grams
the
of fertilizer.
and the plant went up to probably about
14.
14. So, question: eh, any conclusion? Anything you're thinking about between this one and this one so far?
Yes, sir, that when fertilizer is added to a plant, it maybe increases the height of the plant.
Okay, let's go with 10. They added 10 grams of fertilizer, and now it goes up to what?
15.
Okay, when they add 15 grams of fertilizer, it's going to about.
17
All right, 20
centimeters.
grams. 20 grams, and it goes up to.
About 18.
All right. 25 goes up to.
About 21
Mm,
centimeters.
okay. They put on 30 now. And what's happening now?
Yes, sir, it looks like about 19.
Mm-hmm. 35.
Yes, sir, it looks like 16.
What are your conclusions so far?
Yes, sir, that the more fertilizer you add to a plant,
Mm-hmm.
the higher it grows.
Is that true right across the board?
No, sir.
Mm. So up to a point. Is that
Yes,
a
sir,
safe?
up to a point.
Up to a point. All right. So it says here, choose the letter to show whether the following statements are supported or not supported based on the results of the investigation. Let's go with the statements now. Statements, whether we support them, it's supported or it's not supported. All right, let's go with one. Plant height is not, you see this word bowl, not affected by the amount of fertilizer.
Not
Is plant
supported, sir.
Oh, that's not supported. All right, let's go with this one because we can see here that as we add the fertilizer up to a point, it is increasing. After we start adding a certain amount of fertilizer, it is decreasing. True?
Yes, sir. So that
Okay.
probably means that too much fertilizer can cause the plant not to grow as properly.
Okay. All right. We'll come to that. Now it says here, um, two, increasing the amount of fertilizer will always increase plant height. Is that supported or not supported?
Not supported, sir, because in some instances it will increase it, but
Mhm.
sometimes at other times it will not when
Give me
it's too much.
give me an example here.
Sir,
Using the
because
yes.
when we added 25 grams of fertilizer,
Mm-hmm.
that was the point that it kept on going up. But as
Mm-hmm.
soon as we added more grams of fertilizer, it started to decrease the height of
Oh.
the plant.
So when we added 30, we saw a decrease, 30 grams of fertilizer. That seemed to
Yes,
be
sir.
to have been too much. And then we
Yes,
added
sir.
35 and it still was trending down. So those are terms that we will use in looking at stuff like this. So this has an upward trend to the point of 25 grams being added, and above that we start to see a what, a decline in the what, height of the plant. All right, so let's go with the last one here. Fertilizer amounts over 25 grams will reduce plant growth. Is that
Yes, sir.
supported or
Supported.
okay? So that one is supported. All right, thank you. So their tip was, look at each statement carefully. Is the statement supported by the graph? All right. Let's go here. Let me see. Brianna, this one is yours. Again, we are trying to do what? Some to analyze, to interpret data, and now to predict. So we're going to use the evidence and then extend now to the point where we can say, maybe this will happen based on what I've seen before. All right, let's go with it. Question 19. The body temperatures of different animals in hot and cold environments are shown in the table below. All right. We know that when we talk about environment, these are the things around us. Everything around us makes up our environment. We have things that are close to us. We have things that are also in our what? Distant environment. Okay. Um, we think of animals, we think of habitat, we think of all the things that support what? The the life of that particular plant or animal within their habitat and so on. Okay, those are important concepts. Let's go a little further. So this table shows the body temperatures of the animals in different environments. So here we have some animals listed, and then we have the animal body temperature in degrees Celsius. Cold environment, hot environment. So, Brianna, let's go with the what animals are they looking at here?
Snake,
Mhm.
bobcat, fish, and rat.
All right. I don't like any of these snake business here, so on, rat and so on. All right, let's go with this one. So the snake in a cold environment that is 10 degrees, the snake's body temperature is what?
10.
It's 10 as well. Hmm. When the environment is hot, 30 degrees, what is the body temperature of the snake?
30.
Interesting. The bobcat here in a cold environment minus, well, this one 10 degrees, not minus 10, 10 degrees Celsius. It's 38. And then in the hot environment, it's what?
39.
Interesting. Does it move a lot here? Is it moving a
Yes,
lot?
yes, sir. No, not really, because it's moving by one.
Oh, but what about the snake?
The same temperature for
Okay. All right, cool. Let's look at the fish. In the
same
cold.
temperature for
Oh,
10.
okay. Okay. So this kind of reflects what's happening with which of the other animals you have seen so far.
Snake.
Cool. What about the rat?
38 and 38.
Interesting. Let's see now. What are some of the things that we can draw from this? Anyone wants to tell me what the animals are doing here? For example, the rat and the bobcat, what are they doing in science? They have the ability to do what?
Sir,
Sir?
Yes, let me hear you.
to adapt to certain conditions.
Okay. So in this particular case, they have the ability to regulate their body temperature. So let's say we go to New York during the winter. When it's very cold outside, our body begins to do something to keep itself warm. What we begin to, your teeth then start.
Tremble?
Okay, or you could say you shiver, you tremble, right? That's your body's natural response to do what? To raise the temperature. So just like or to keep it in a nice range. So you don't have ranges that swing like the snake here. It's the same, whatever the conditions are outside, that will be its temperature. But for the bobcat and the rat, whatever the conditions are outside, they stay relatively what? The same. Okay, 38, 39, 38, 38. So that's something that we need to note. All right, let's go a little further now. A student placed a snake and a rat in an environment at 25 degrees Celsius. Based on what you have seen so far, let's go now. Which body temperatures are they most likely to have after a few days? Now, what they say you must do here, examine the results in the table. What patterns do you see? And use the patterns to make a prediction. All right. So let's go with this. What's your thinking on that one, Aubrey? So then move the rat and the snake and put them now into this where the environment is 25 degrees Celsius. What body temperature are you most likely to see after a few days? Not hearing you.
Sir, both of them are going to adapt to the temperature. I would say both are 25, or I would say 20, snake would be 20 and rat would be 25.
All right, let's go back to our table and see if that's so. What happens? What happens to the snake when the time is cold?
It is the same, adapt to the environment.
So it stays the whatever is happening outside, that's the temperature there. If it's cold, when it's hot, what happens to the snake? The
It's still
temperature
the
is
same
the same.
temperature.
Let's look at the rat. In an environment that is cold, it's 38, and in an environment that is hot, it is still 38. So he keeps his body temperature the same. The snake, though, does not keep his body temperature the same. So if I put him in an environment that is 25, what should happen to the snake based on what is observed here? What should happen to the snake? The snake should have a temperature of what?
The same 25 Celsius.
Good. All right. So automatically, we know it can't be A, it can't be what? It can't be C, and it can't be D, because the pattern observed is that whatever the outside temperature is, that's what the snake will be. All right. So we automatically see that the snake should be what? 20, 25 degrees Celsius. Let's go with this. What about the rat? We recognize that when the rat was in the area that was cold, he had a body temperature of 38 degrees. And even when it was hot, he still had a body temperature of 38 degrees. So we can say that he's trying to keep his body temperature constant or regulate his body temperature. Let's go with this one. So the rat placed in this 25 degree Celsius place, what will he try to do?
Sir, could you repeat?
What will he try to do? What will the rat try to do? Because here, based on the table, we recognize that the rat had it when it was cold, he kept it at 38, and when it was hot, he still kept it at 38. Now I'm going to put him in an area, an environment at 25. What will the rat try to do?
Sir, the rat will maintain the same temperature.
Good. So what was his temperature here based on what we saw? 38. So the rat would be what? Most likely to keep the temperature at 38. Now, here they have rat at 38 down here, but why couldn't I use this one as my overall answer? Why not? Why I can't use D?
Because sir, the snake adapt to whatever environment it is.
Okay, so the snake's temperature will be whatever the temperature outside is. So here, if it is 10, the snake is 10. If it is 30, the snake's temperature would be 30. Since it is that the outside conditions are 25 degrees Celsius, we expect that the snake will also be 25 degrees Celsius, but the rat will try to keep his body temperature the same in all situations. All right, thank you for that one. Let's go. I see 10.
Yes, sir.
This one is yours. We're going to do some data analysis now, targeted skills, analyze and interpret the data and draw certain conclusions. Let's look at this. Question 20. A student measured the time it takes for water to pass through different soil types. The diagram of the experiment is shown below. The table shows the results of the student's investigation. So here we have different things in science. We can talk and call them apparatus and all of those fancy terms, but when you get to high school, you'll use more of those. So here we have a measuring cylinder. We have filter paper. We have the soil. We have water, and we have a funnel. Okay, all of these things are being used in our science investigation. Let's look at this. It says analyze the results in the table. Which soil held the most water? How quickly did water pass through each soil? Let's go with this now. So the table is showing the volume of water and the time taken for different soils. So we have clay, loam, and we have sand. Okay. What do you know about clay, sir?
It's the soil that has the particles closely packed together.
Okay. All right. So particles closely. What you know about loam?
It's a mixture of two soils and it's good for growing crops.
Okay. All right. So garden soil, good for growing thick. What about sandy soil?
Sand soil, it has the least water holding capacity.
Oh, I love that term. Water holding capacity. All right, let's go with this. So volume of water added to the soil in centimeters cubed. Because remember, we're dealing with volume and we use centimeters cubed, cm cubed, to represent volume. All right, let's go. So when they added to the clay, they added 30, 30, and 30. Hold on. The other day we were talking about this concept. Fair test. You have to use the what? The same amount for each of them to make it a fair test. Let's go now. So they kept the amount of water the same. Now the volume of water collected in the cylinder. So look here after so the same amount of water is added to all of them, but different amounts will be collected, because here they say for clay, they collected only what?
24.
24 cc's or cubic centimeters of water. They collected 27
Cubic centimeters of water.
and here for sand they collected what?
29 cubic centimeters of water.
Let's look at the time it takes for all of this to happen. Time for the water to pass through the funnel in minutes. So for the sand, it takes only
1 minute.
For loam, it takes
2 minutes.
And for clay, it takes all of what?
5 minutes.
All right, let's go with the information again so we get it. Again, what is the tip? Analyze the results in the table. Think about which soil held the most water. Think also how quickly did water pass through each soil. And we dealt with this before, and we talk about the what? Water holding capacity of various soils. And we can see based on this that they are not the same. What did they do to make the test fair? They gave all of the soil types the same amount of water. What was different? There's difference in the amount of water collected and also in the time taken for the water to be collected in the measuring cylinder. Now, based on that, sir, choose the letter that completes the conclusions below. Water takes longer to pass through which soil?
Clay soil.
Very good. What and why do you think so?
Because it takes in the diagram presented, it takes 5 minutes for clay soil, and for loam it takes 2 minutes, and sand it takes 1 minute.
Yes, you're telling me what you observed there, but I'm just pulling away from this a little bit to say why. What about clay would cause the length?
Because the particles are packed closely.
All right, very good. Let's go on now. So it says here, looking at this one, which of the soils has the least water holding capacity of the soil types?
Sand.
Okay, so of all of the soil types, sand is the one that holds on to water the least. Let's look at this. You notice that they place 30 cc's of water in the sand and they got back almost all of it in 1 minute. You see that?
Yes, sir.
They got in 1 minute, they got 29. They put in 30 and they got what? 29 back. So it gave back almost every cubic centimeter that was added. Look at the loam. They gave it 30 and it gave back 27 cc's there. Okay? And that happened in 2 minutes. So it holds on to some water, right? But look at the clay. They gave it 30. They got back 24. That took 5 minutes. So the clay holds on to more water than any other soil type. And the sand does what? It doesn't hold on to water at all for the most part. Just a little bit. In this particular setup, only 1 cubic centimeter of water it would hold to. Okay, or hold on to. All right, thank you for that one. Let's go to 21. Still with you, Tane. Let's go with this one. A student wants to find out how the temperatures of water affects the time it takes a sugar cube to dissolve in water. Let's look at this. He does the experiment 3 times at 4 different temperatures. Why is he doing this though? Why does he keep doing this experiment over and over? We did this in class before. What did we say about this? Why do scientists do the same things over and over?
To find different observations.
Or to see if the observations are true every single time.
Time.
Okay, we could use the word to see if the results are consistent. All right, think about this. So he does this 3 times at 4 different temperatures. Let's go with this. He uses 1 sugar cube each time and the same volume of water. Why is he using the same 1 sugar cube and the same volume of water? Because he wants it to be
Fair test.
a fair test. Excellent. The results are shown in the table. So consistency and using the same things for the fair test. And as scientists, we document our results so that we can do what? Analyze them. Then we can use them to draw conclusions and to make predictions. All right, let's go again. Table here showing the time taken for the sugar cube to dissolve at different temperatures. Let's go. Temperature here. Test 1, test 2, test 3. So he does it with 30 cc's here. And when you put, no, well, not 30 cc's, 30 degrees. The water is 30 degrees. When he did the first test, it took 10 minutes to dissolve the sugar cube. He did it again, it took 9. He did it the third time, it took 11. All right? Let's go with this one. At 40 degrees, how long did it take?
It took 8 minutes for the first test. For the second test, it also took 8 minutes. For the third test, it took 9 minutes.
All right, cool. Now, he made the water, warmer, getting all the way up to now, what, 50 degrees Celsius. For the first test, what was the time taken?
7 minutes.
What was the time taken for the second test?
7 minutes.
And the time taken for the third test?
8 minutes.
All right. Now he makes the water go all the way up to 60 degrees Celsius. What happens here for the first test? Time taken?
6 minutes.
All right. Time taken for the second one?
6 minutes.
Time taken for the third one?
7 minutes.
All right. Now, look at the tip. It says here, look for patterns, compare how quickly the sugar, dissolved at different temperatures. So let's look at this. At the temperature here, at 30, 10, at 40, 8, at 50, 7, at 60, 6. What? You see any trend, any pattern?
Yes, sir.
Tell me
Every
what you see.
time the water goes up by 10 degrees, the
Mhm.
time lessens.
Okay. So if it was at 30 and it move up to 40, you should take less what?
Time.
Time. All right, let's look for test 2. Test 2 at 30 it was 9, then 8, then 7, then 6. That seems to be the same thing, right?
Yes, sir.
What about test 3? What are we observing for test 3? As
It
the
went from
temperature,
11 minutes,
so
9 minutes to 8 minutes to 7 minutes.
all right. I think we can try the question now. Which statement best describes the pattern of the results? Let's go. A.
The, the,
Read for
mo-
me.
the more water used, the shorter the time taken. No,
Mm-hmm.
I would eliminate that one.
All
The
right.
higher the temperature, the longer the time taken. I would eliminate that one as well.
Why you going to eliminate this one?
Because it says the longer the time taken, when it would be shorter because the
Mm.
temperature is rising. So the time should be shorter, not longer.
Okay. All right. So C.
The more water used, the longer the time taken. And I would eliminate that one. The higher the
Why?
temperature,
Why would you eliminate C?
because it doesn't give any. information about what more water does to the sugar cube.
But not only that, the relationship we want to establish is the relationship between what? The temperature and the what? Time taken for it to dissolve. All
Melt.
right. So go with B.
The higher the temperature, the shorter the time taken. I would pick B.
Right. So the higher the temperature, the shorter the time taken. Good work with this, sir. All right, let's go back to Tess. Tess, item 22 is yours. All right, let's go. We have question
Yes,
22.
sir.
Read it for me, please.
A class investigated the habitat preferred by woodlice. They set up a choice chamber with four sections W, X, Y, and Z, representing different habitats for the woodlice.
So here we have the this diagram here. So we have the choice chamber, W, X, Y, Z. Here the wood lies. The class released, read for me.
The class released 20 woodlice into the chamber and counted how many woodlice were in each section after 5 minutes. These are their results.
Let's look at the results. For section W, what was the
It
description?
is dry and light,
Okay, and how many of them were in there?
2 woodlice.
All right, so after 5 minutes, only two stayed here. For this one, X, it was what?
Damp and light, and
And
5 woodlice were in there.
what about Y?
It was dry and dark,
And we
and
had,
3 were in there.
okay, Z.
It was damp and dark, and 10 were in.
All right, let's look at the hint. It says, compare the number of woodlice in each section. What is similar about the sections that had more woodlice? Let's go with this. So let's go back to this. Which sections have more woodlice?
Z, sir.
Sections.
Try Z.
Okay, you're looking at one. I want to hear sections. Look at what they said
Oh,
here.
in order?
Well, it doesn't matter whether it's in order. Let's identify the sections that have more.
So Z and X.
Good. So now that we have identified the sections that have more, let's go with what do they have in common. Let's look at the
They
description.
are both damp, sir.
They're both damp. All right. Let's look at the others then. W and Y. They are both what?
Dry.
Okay, okay. So it says here, what conclusions can the class make from the results?
So A, woodlice prefer dark habitats. I would not go with that because in the dark habitats we can see that 2 and 3 were in the dark the
Mm-hmm. We have dark and dark here. See?
sir, but it does not like the dry part.
Ah, okay. All right, cool. So go with some, let's continue and
So
see
I
what
would
happens.
eliminate A.
Mm-hmm.
And B says woodlice prefer damp habitats.
Mm-hmm.
Yes, sir.
All right. So we're going to
I
hold
would
on to
keep
this
that
for a
one.
while. All right.
C, woodlice prefer dry habitats. No, sir, because for the dry habitats, we can see that only 2 and 3 woodlice were in there. So less would be in the dry than in the damp.
Mm-hmm.
And woodlice prefer the light. No, sir, I would not go with that one.
What are you left with then?
So I would be left with B.
So woodlice prefer damp habitats. So the habitats were what?
W,
Damp.
X, Y, and Z.
Mm-hmm. And even when there was some amount of light, they still preferred the area to be what? Damp rather
Dark.
than dry. All right, cool. All right, let's go on. Almost done. I think this is, we only have two more after this one. Let's go with Brianna. Brianna, this one's yours. A student investigated the strength of different types of paper hanging by hanging different masses on the paper until the paper tears. So they're looking at the what? Strength of the paper. What is this again? What area of science is this again? What topic this falls under?
Material, sir.
Materials. And in particular, what property are they looking at? Is
The
it
strength,
flexible? Okay, so other properties that you know about include
absorbency,
absorbency, yes, that's one.
conductivity,
Conductivity,
waterproof.
if it's waterproof, if it's what? Rough,
You
smooth, rigid, magnetic, so those things like transparent and so on. Okay, those are some of the properties. Let's look at this. So it says here, so see, we can see, yes, we have some mass here. We have the paper and it's attached to this arm. All right. The results are shown in the bar graph here. So bar graph, strength of different papers, and we have number of masses needed, I guess, for it to tear. So we have 0, 1, 2, 3, 4, 5 on the y-axis. On the x, we have newspaper, tissue paper, printer paper, and writing paper. Let's go. What's the hint? The hint here is, read for me.
The hint is saying analyze the information in the graph.
All right. So it says here now, let's look at it. So for the newspaper, how many of the weights or the masses we needed for it before it tear?
2,
For the tissue paper, how many?
1,
For the printer paper?
3,
For the writing paper?
4.
All right, cool. Now it says, which type of paper was the strongest?
Writing paper,
Why not the tissue paper?
because it is the lowest.
Oh, so it means with the least amount of what? Weight, it will tear. But for the writing paper, we had to have what? The most weight added to it before it would tear. Do you agree?
Yes, sir.
So what's your answer again? Which type of
Writing,
paper is the strongest?
writing paper.
All right, good. Very good with that one. Let's go back to 10. This one is yours, 24. All right, 24. Where are we? 24. We just did 24, 25. Let's go 10.
Yes, sir.
So a student investigates friction by pulling a block and recording the force needed using a force meter. The results are shown in the table. Use the information to answer items 24 and 25. So here we have the block, we have the force meter, and we have someone pulling on it. All right, let's look at the tip. Analyze it. Read the tip for me, please. Analyze.
Analyze the information in the table. What pattern can you find?
All right, so we're looking for a pattern. Let's go with this. So here's the table showing the force needed for different surfaces. So we have the surface and the force needed in newtons. All right, so force is measured in newtons. All right, cool. So here we have tabletop, paper towel, fine sandpaper, and rough sandpaper. Let's look at this. On the source or tabletop, how much force do we need?
2.5 newtons of force.
Good. What about the paper towel?
2.8 newtons of force.
What about the fine sandpaper
3 newtons of force.
and the rough sandpaper?
3.3 newtons of force.
Hold on, let's go back to the tip. It says, what pattern can you find? Hold on, let's look at it. Pattern. Any pattern?
Yes, sir.
Tell me the pattern you see.
Every time the material gets rougher,
Mm-hmm.
the more force needed.
The more force is needed. All right, cool. Let's look at the question then. What is the conclusion for this investigation? A. Force moves objects on different surfaces. B. Force stops objects from moving. C. The rougher the surface, the greater the force needed. D. The smoother the surface, the greater the force needed. What say you on that, sir? What's your thinking?
I would say C.
Read your response for me.
The rougher the surface, the greater the force needed.
All right. Good one. Look at this, and I can look at fine sandpaper and rough sandpaper. Fine sandpaper, we only needed 3 newtons. And for the rough sandpaper, we needed what? 3.3 newtons. Let's go with 25. Oil.
Oil is added to the tabletop. Which prediction will likely take place?
Mm-hmm.
A. The force needed would be 2 newtons of force. The force needed will be 2.6. The force needed will be 3.1. The force needed will be 3.4. I would say A because all the lubricants of
Okay.
force, all the lubricants, so it makes stuff go faster, so it's more slippery. So I
Mm-hmm.
would say A. The force needed will be 2.
All right. So let's tidy up something. So the lubricant reduces friction. Understood?
Yes, sir.
So friction will be between the what? The block of wood and whatever surface it's on the tabletop here. Now, when it was just by itself, no oil, no lubricant, we needed 2.5 newtons to move it. If we add the lubricant and reduce the friction, we are going to need less force. So we can't have 2.6 newtons now because that was more than before. We can't have 3.1, we can't have 3.4. We should have what? Less than the 2.5. And the only one that is less than 2.5 would be option A. Force needed will be 2 newtons. Thank you very much, sir. Test 26 is yours.
Ye-
26.
Yes, sir. Some students were carrying out an investigation to determine the best material for soundproofing. These are the steps carried out. They measured the sound level of an alarm from a phone in an open box. They then measured the sound level of the phone alarm in the following situations.
Mm-hmm.
Number one, when the box was closed, and number two, when the box was packed with different materials and closed. The results are shown in the table below.
Mm-hmm.
So we have two columns.
Mm-hmm.
The first one shows where the phone alarm was placed,
Mm-hmm.
and the second one shows sound level in decibels.
Very good.
So in the open box, it was 80 decibels.
Mm-hmm.
In the closed box, it was 70 decibels. In the closed box packed with bubble wrap, that would be 40 decibels. In the closed box packed with cotton, that would be 50 decibels. In the closed box packed with fabric, that would be 55 decibels. And in the closed box packed with paper, that would be 60 decibels.
All right, let's look at the tip. Analyze the results and use the information to draw conclusions. It says here, which material is best for soundproofing the box? Now, what soundproofing means again? When you did sound and we spoke about noise and soundproofing and sound treatment and what you understood soundproofing to be?
To reduce noise levels,
Okay, all right. Why is it important to reduce noise levels? Why?
because, for example, sound
Mm-hmm.
levels over 85 decibels can damage the ears and cause loss of hearing.
Okay, okay. What are some of the other ill effects of noise?
Mental stress,
Mm,
yes, sir. It can cause insomnia.
loss of concentration, and so on. All right, let's go with this then. So, which of the materials is best then for soundproofing the box? Is it bubble wrap, cotton, fabric, or paper?
Yes, sir. I would choose bubble wrap because we can see that in the closed box packed
Mhm.
with bubble wrap, the sound level was only 40 decibels, so it reduced a lot of the sound.
Versus when the box was open or when the box was closed.
Closed.
No other material got it all the way down to what? To 40
40
decibels.
decibels.
Good thinking on that one. Stay with me here. Let's go with 27. A
Yes, sir.
student wanted,
A
read
student
on.
wanted to determine which material could keep her soup warm for the longest time. She carried out the steps below. First, she placed the same amount of soup in cups made of different materials A, B, C, and D. Secondly, she measured the temperature of the soup in each cup at the beginning and at the end of 10 minutes. The student obtained these results. So, sir, we have three columns showing the material, the start temperature in degrees Celsius, and the end temperature in degrees Celsius also. So in material A, the start temperature was 70 degrees Celsius and the end temperature was 56 degrees Celsius.
Mhm.
And B, it was 70 degrees Celsius and the end temperature was 51 degrees Celsius. In material 6, C, the start temperature was 70 degrees Celsius and the end temperature was 61 degrees Celsius. And in material D, the start temperature is 70 degrees Celsius and the end temperature is 62 degrees Celsius.
Let's see our hint. Our hint says analyze the results and use the information to draw conclusions. All right, let's go with this one. Which material is the worst insulator? Hold
Yes,
on,
sir. So
before
we know
before you
that
answer,
insulators,
tell me what an insulator is.
yes, sir, insulators are types of materials that keep the hot out and keep things cool.
Hmm. Let's
Mm,
phrase that
they're the
another way.
opposite of conductors.
Okay, so we could say that insulators are poor conductors of heat.
Heat.
All right. Let's go then. So they are
Yes, sir.
not
So the
they
question
are not
says,
good insulators then, because if it's a worse insulator, that means that they are not good insulators. So which material is not a good insulator here?
sir, that would be material D.
Material
D.
D.
Yes, sir. Because it kept most of the heat inside the cup.
Mm, that would make it a good insulator then, because it kept most of the heat inside. The heat did not escape. Understand?
Um, yes, sir.
Think about it again and let's go. Insulators are not good conductors. So a conductor will allow the heat to escape easily. An insulator, a good insulator, will slow heat loss. Okay. So if it's, and when they say the worst insulator, that means that its conductivity is good. Which one of these materials here would have the best conductivity based on what you're seeing? Is it A, B, C, or D?
Yes, sir. The best would be D.
D? Still not agreeing with you there. Let's look at B. If it is a good insulator, and let's put it in context. It says, listen to this now. Which material could keep her soup warm the longest? Look at this. Remember now temperature. When you started, you had 70 here. When you finish, it was all the way down to 56. So this means it's getting what? Cool. And you want to keep it warm the longest. Remember, okay? Remember, the closer we get to 0, the cooler it is. The higher or closer it gets to 100, the warmer it is. All right, let's go. So we all start at 70. But after the time of 10 minutes, when we check the end temperature, this was at 56. This was at 51. This was at 61. And this was at 62. So which one of them is the worst insulator?
Yes, sir. Material B.
Material B. Why? Because it what? It allowed more heat to escape than any other material. Understood?
Yes, sir.
So we have refined our thinking on this one to identify material B. Because remember, we want it to be kept what? Warm, the soup, to keep our soup warm for the longest time. If I keep it in material B and it's already here, after 20 minutes, it's not going to be very warm at all. But if I keep it in material D, which I identify based on this to be a very good, of all of these, the best insulator, I have the best chance of it being kept warm for a longer period. All right. So the terms here that we need to figure out properly are worst and insulator, and to think of them in terms of what? The conductivity, that property of conductivity. Okay. All right. Let's go here. 28. I think after 28. All right. Let's see if we can push through these quickly. All right. Let's go and just finish this booklet. All right. So 28 panelists. Mr. Smith wants to determine the best brand paper towels he should use in his kitchen to soak up water by carrying out an investigation. The number of pieces of paper towel used to soak up 150 milliliters of water in each case is given in the table. All right. So we have about 5 minutes left to finish up these questions here. So paper towel and the number of pieces used. For brand A, he used 8. Brand B, 4. Brand C, 6. Brand D, 5. Now let's go. It says, tip, analyze the results and look, will the best brand use more or less pieces? All right, let's go with this. Which is the best brand paper towel for Mr. Smith to use? Is it, panelists, brand A, B, C, or D? Any one of you?
Sir,
Yes, sir.
brand
That would be brand B.
Brand B uses 4. Why is
Yes,
this
sir.
the best
Because it
one?
uses the least of all.
Okay, which means that it is the most, let's work a word in terms of,
Absorbent.
very good. So it soaks up more water than any other brand. So it uses the least number of what? Pieces to soak up the most water. All right, let's quickly move on then. Adding baking soda or powder to vinegar in a bottle can create a rocket. A student wanted to find out what? A student wanted to find out? Somebody tell me.
The amount of baking soda would affect the height of the rocket.
Mm-hmm. If the amount of baking soda would affect the height. The results are shown in the table below. Use the information to answer items 29 rather. So here we have the rocket and we have the things needed, vinegar and baking soda. And when we add these, we're going to get a chemical reaction, right? And I know that you guys know about the Mentos challenge, and you put those Mentos type sweeties into, what is it? Coke or
Cool.
Pepsi or any cola, and you will get a reaction there. So something similar to that. Let's go with this. The table now showing the amount of baking soda and the height of the rocket formed. So tip, analyze the table, the information in the table. What pattern can you find? Number of teaspoons, 1. What is the height there?
70
Centimeters.
centimeters, sir.
Number of tablespoons, 2. How high does the rocket go?
130 centimeters.
When I add 3 teaspoons, how high will the rocket go?
170 centimeters.
When I add 4, how high will the rocket go?
180 centimeters.
What is there any pattern that you see?
Yes, sir. The more teaspoons of baking soda you put into the um rocket, the
Mm-hmm.
higher it goes.
All right. All right. So again, we need to pay attention to the patterns if there are patterns there. All right. So let's go with this. What is a likely conclusion from his investigation? Is it A, as the amount of baking soda increased, the rocket height increased? Or is it B, baking soda reacts with bottled vinegar? C, if the amount of baking soda is increased, then the rocket height will change. Or D, when baking soda and vinegar are mixed, a rocket is produced. What say you?
Yes, sir. I will go with A.
And A says,
As the amount of baking soda increased, the rocket height increased.
so the conclusion that you would draw from that would be,
That the more baking soda, the rocket height increases.
all right, cool. All right, let's go with this one. I think this is the last one. Praise the Lord. Last one here. Let's go. Um, the graph shows the length of some piano strings and the pitch of the sound they produce. Let's just take the word pitch. What pitch means again in science?
How high
How
or
low or
low?
high
How
a
high
sound
or
is?
low? All right, cool. So we're on point there. Let's look at this. We have I hope we have students who play music, in particular the keyboard, and we have here various keys, okay, and then we have here the string length, right, and this is in relation to the percentage of C1 length. All right, so here we have 0, 20, 40, 60, 80, 100, and these are going to be, all the others will be based some comparison to this. So C, then D, then E, F, G, A, B, and C. Okay, so one octave here. Okay, going from a low C to a higher C. All right, so that's just a little music theory there. So if we look at this here, the piano key, C1 low, D low, E and F are medium, G is medium, A and B are high, and C2 is high. So we're going from low on the left, and as we move to the right, we go higher. Okay, and as we move from the right to the left on the keyboard, we go lower. Let's go with this one then. It says here look, use the information above to answer the question. Now it says here, look at all the information given, check if each statement is supported by the information. All right. So what do we know about the strings and pitch? Tell me what you know about strings and pitch. Anyone is free to go ahead. All right, not thinking of anything there. Waiting for an answer.
The pitch of this
Mm-hmm.
the pitch of the string may depend on the density.
Well, in this case, we are looking
Sir,
at length. We're looking
the
at,
thickness.
well, we're looking at length. So the longer the
The
string,
longest string will give a low pitch sound, while
okay,
the shorter strings will give a high pitch sound because they vibrate faster.
very good. So the longer an object is, the what? The lower the frequency, right? And therefore we get a lower pitch. The what? Shorter the object, the higher the frequency, and we'll get a higher pitched sound. So those are things that we have to remember. All right, so let's go now into the last one here. Which statement is true? A, the piano key C1 has the shortest string. Let's look. Does C1 have the shortest string? Let's look at this graph here. This one has the shortest string. It goes all the way up to 100. Shortest string, this one, C1. Answer yes or no.
No.
No, sir.
All right, cool. Not the shortest one. What the piano key C2 has the longest string. Let's look at C2. C2 stops here just below 60.
No,
In
sir.
fact, C2 is the what? The what? Which one?
Shortest.
Okay, all
Shortest.
right, cool. Let's go with this one. The shortest string, the shorter the string, the higher the pitch of the sound.
Yes, sir.
That appears to be so.
That's true.
That appears to be so. All right, let's go now here, because look at it. This is a long string and this is the shortest string. So as the strings get shorter, look at it. As we move from C to D, and you notice it's getting shorter and shorter, and we go to F and then G and then A and then B. So as they get shorter, they get what? Higher. All right, so we'll hold on to that one. We have to look at D. The longer the string, the what? The higher the pitch of the sound. Is that supported by our information here?
No, sir.
All right. So what is supported?
C.
C. The shorter the string, the higher the pitch of the sound. Guys, thank you very much for staying on for so long. At least we got to go through the rest of the booklet. Please remember to go through your reflection. Remember, ask the question, what aspects of the task did I find most challenging? What were the parts that were easy to complete? Which quantitative reasoning category do I need further help with? And if you need help, go and find help. Talk to mommy, daddy, talk to your teachers, drop us a line. We're always trying to help you. Then you can do your self-check. Just remember, you might not be sure of certain things. You may not achieve certain things yet, or you might be totally comfortable with certain things. All right, guys. Again, thank you for staying. It was a long one, but I really appreciate the effort made by you as we looked at quantitative reasoning. Thanks, guys, for joining. Take care, and I'll see you in our next episode.
Bye bye.